History Museum and our demonstration of Babbage's Difference Engine number 2. This particular one is Difference Engine number 2, Serial 2. What is this machine and why is it called the Difference Engine? It is essentially 7 stacked up adding machines, and by adding machines I mean literally that, not adding, subtracting, multiplying, dividing, square rooting, natural logarithms, etc. machines. I mean adding, okay? And it uses a method called the method of finite differences for evaluating polynomials. In the day, you did complex calculations by looking up things like sines, cosines, arctangents, logarithms, etc. in big tables. The tables were computed by people. And the vast majority by number of those people were doing what this machine does. Adding a number to another number, that number to another number, that number to another number, that number, blah, 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 up to the end, to the result, and then starting back again. And you see things moving up and down. Those are the pairs that actually couple them together, adding either the odd columns to the even or the even columns to the odd. It's like a little transmission for each set of number wheels. One of Babbage's pastimes was to sit down with his friend John Herschel and proofread books of mathematical tables. But by taking, one publisher's table and another publisher's, the same allegedly table, and comparing them. When they differed, clearly there was a problem, right? So the essence of Babbage's invention here was that not only would the calculations be done by machinery, and by machinery which would either get the correct answer or stop, but the results of the calculations would be directly typeset by the machine, untouched by human hands, so to speak. So this was the grand vision. He had a small kind of mock-up, which is now called the beautiful fragment, made of this machine, and he would show it to anyone who could look at these soirees that he used to give in London. Eventually, although he was not much of a businessman or people person, he managed to talk the British government into supporting the development of the difference engine. The primary argument that kind of won the day was, look, these tables are used in navigation. If a ship captain uses these and there's an error, he could show up late for a battle or run into rocks. He convinced the British government to fund this. He got one of the best mechanics, which at the time meant machinist or mechanical engineer in today's terms, And after 7 years and 17,500 pounds expended, they were a little less than halfway through. And at this point, the government's patience ran out. And they pulled the plug. And even worse, Clements owned all the parts, the half of the parts that had been made. So he scrapped them, recovered the bronze, etc. And all that Babbage had to show for the difference engine, which we now call difference engine number 1, was that beautiful fragment. So I said it would get the right answer or halt, and now you're going to check me. This is evaluating the polynomial r equal 8x to the 7th plus 2x to the 6th plus 9x to the 5th plus 5x to the 4th plus x to the 3rd plus 7x squared plus 4x plus 41. It just happens to be one of Babbage's favorite polynomials. 7, 1, 6, 0, 6, 0, 6, 5, 8, 9, 4, 2, 6, 2, 5, 0, 1.
Yep.
All right. One of the little modifications that's been made to this machine is we have a 4-to-1 gear reduction here so that normal people like Lowell and I can crank this machine. So each time you see him crank it 4 times is really what Babbage considered 1 cycle of the machine. It just would have been darn difficult to do. You'll hear, if you're watching him and keeping track of his strokes, you'll hear during each one of those full cycles, several times you'll hear this thwack. And as you watch the machine, which now you're going to know a little bit about what it's doing instead of going woo, these wheels are going to rotate towards each other and then back. That one's going back, that one's not. And pairs of columns are going to do that. And at sort of the ends of that motion, these things that look like, you know, draw knives or sling blades or whatever are going to go whack into the gear teeth. So that, because the gears have backlash and stuff, so what makes this a digital computer as opposed to an analog computer is that although numbers are represented by the positions of gears, they are quantized at the end of every step. In other words, 3.1 becomes 3, as does like 2.78, you know. So there's no such thing on a gear here as a digit that's like part of a digit, okay? If somehow this has gotten awry to some extent so that the machine can't decide whether to round to 3 or 2 or 4, those bars will hit the ends of the teeth, it will stop, he will go, ugh! And we will figure out what went wrong, but it didn't produce a wrong answer. So that's what's really important. Now I said the wheels rotate toward each other, so what happens is, say, this set of wheels rotates down until the wheels have been zeroed out. So obviously if the wheel had a 1 in it, it's not going to move as far as if it had like a 9 in it to get down to 0. While they do that, these things in between are meshing with the wheel next to it, so this wheel is going up by the amount that this went down. Then they get disconnected and these get set back to what they were, so they're ready for the next time. What happens in this column? Well, what happens when you add, say, 8 to 4? You can't fit 12. These wheels only go 0 to 9. So what you have is a 2 and a carry. But this thing is busy. This is locked into this gear. You can't have 2 things trying to move it at once. So while these guys are resetting, carries are taken care of on here. So if you split and go around, we show you the other part of the addition. When a wheel is moved from 9 to 0, a little tab kicks out one of these little bronze levers. And that's called warning. It is warning of a carry. Each one of these little arms here moves along, and if a carry was warned on a wheel, it will make the carry to the next wheel up and move the lever to another position to say, done. They're spiraled so that a carry in one position can create a carry that will be picked up by a lever traveling behind it. And can go all the way up the column of 31 digits, or almost up all the way, because these levers, it's another example of Babbage cleverness. These levers have a fourth position where they are inactive. And the purpose of that fourth position is so that the columns can be split, well, the entire machine can be split horizontally. And in our case, we're using the bottom 4 digits to just keep track of x. The function there is just adding 1 every time to the result. That's how I knew that we're at x equal 190. Then the carry is disabled from that position, so it can't pollute the rest of the result, which is the actual result of the polynomial. So you could do all sorts of stunts. You could split the machine any way you want, sort of like the SIMD instructions on your x86-64 or whatever. You can do multiple calculations at once. While there were no plans for the analytic engine, later in life, Babbage did come back to the difference engine. He left complete drawings for this machine, allegedly having said, another age must be the judge. Difference engine number 1, had it been built, would have had about 25,000 parts and have been 2 or 3 times as heavy as this one. This machine has only 8,000 parts. About 4,000 of them are here, and the other 4,000 are here. The way this works is it's adding all the odd columns to the even columns, and then all the even columns to the odd columns. But what happens here? Well, essentially what happens is that this is added, so to speak, to 0, which throws it over into this end of the machine, and through all these levers and stuff, this actually produces the printed result. Now, it not only, of course, prints, so to speak, it also sort of typesets. There are various options in here for selecting how many columns on a page you're going to print, how many lines of numbers you're going to have before you sort of skip a line to help guide people's eyes. Quite a fascinating formatting engine, so to speak, for this. This is half the complexity of the machine. When this reaches the end of the page, it yanks on this cable here and actually disconnects the crank from the machine. So he's like, whoa! But the machine doesn't go any further. Oh, I guess it's time to change the type tray.
After the last second. Yeah.
So Babbage actually thought of a great deal in anticipation and never built a single piece of this machine. Scheduled for 1991, a guy named Doran Swade was looking around for something cool to do for Babbage's 200th birthday. And someone mentioned, well, we have this set of plans down in the basement that he did for a successor to the difference engine. And at the time, as I said, there was a bit of a debate whether Babbage was a man ahead of his times or just a nutter. No way Victorian technology could have built something like this. Ridiculous. The basic premise was they had the beautiful fragment, so they could analyze it to see what the properties of materials available to Babbage were. They could also measure the parts very carefully to see how much variance in the dimensions of the parts were. They knew both the materials it would have been made of and the level of workmanship that was achievable at that time. And so a rather grand enterprise was entered into, which culminated in this much of the machine being available for Babbage's bicentennial. But in a phrase that is familiar to people who read or talk about Babbage, they ran out of money. But Bill knew a guy. He's also a bit of a collector and CTO of Microsoft at one time. So he also has money. So he came over and the museum said, yeah, it's cool, but you know what we really need is the printer. And they says, no, what you really need is to build one for me. And I said, no, but what we really need is the printer. He says, okay, deal. I will fund your development and construction of the printer for your difference engine if you will make me one. So this is difference engine number 2. That is the second design of the difference engine. Serial number 2. This does not belong to the museum. It belongs to Nathan Myhrvold. It will, in theory, eventually be displayed in his living room near his Tyrannosaurus Rex skeleton. And for that reason, those of you who have come close enough to see the oil dripping through it, that is not a bug, it's a feature. That's how you lubricated equipment in Victorian times. You poured oil in the top and it eventually collected in the pan on the bottom. And, that oil that we're using is slightly non-Victorian. It's a food-grade oil, which means it doesn't smell like old machinery, which was a requirement of Nathan's wife. We have been lucky enough to several times get an extension of Nathan's loan of this machine to us. And each year we hope that he will extend that another year. And so far, he has. But I would recommend that you all go home and tell all your friends to come see this year, because it may not be here next year.